All right, good afternoon, everyone. We'll just give it a few seconds for allow time for everyone to join in and join the live webinar. I can see the attendance, the participation, or the attendees count is building up slowly. I'll just give it 10 or 15 more seconds before we start so that we have most of the people in. All right, I can go ahead and get this started. Welcome everyone to another one of the MEA's webinar series. Today we have Civica Infrastructure to talk to us, so present to us about innovations in infiltration and inflow tracking and monitoring. We have our speakers today is Edward Graham, President and CEO of Civica. Edward has 30 years of municipal water resources and software engineering experience, focusing on wastewater, stormwater, and drainage infrastructure. His experience includes drainage system capacity management, master planning, program development, and specific technical analysis and analytics. Joins us also is Matthew Malone, Vice President Business Development with Civica. Matthew has accumulated a wealth of experience in the areas of wastewater and stormwater capacity assessment and management, with high-level expertise in capacity management, stormwater management, flow monitoring, and inflow and infiltration programs. Matthew's previous experience as a project manager for the region of Peel allowed him to gain insights into the key challenges faced by municipalities managing water and wastewater assets. Before I hand over the mic to Matthew, I would like to remind everyone that you can ask any questions during the webinar. We'll just answer it at the end of the webinar, but we encourage you to type your questions using the Q&A function. If you hover your mouse at the bottom of the screen, you'll find the Q&A function. You can type your question there and we'll address it at the end of the webinar. And when we open the floor for questions, if you're more comfortable asking the questions verbally and not typing it, feel free to click the raise hand button. We'll give you permission to turn on your mic and ask you the question verbally. Without taking more of your time, I'd like to hand it over to Matthew to start the presentation.
Awesome, thanks, Amin. And thanks to the MEA for having us today. We were connected through, we have our own webinar series that we've been putting on for the last year or so, and I think Dave Bangla, York Region, was at our last webinar, and he was able to connect us and with him in and set this up. So thanks to Dave, and thanks for everybody for coming, and thanks to the MEA for inviting us to hopefully engage with you and hopefully have a good discussion at the end and see if we can pass some value on to those that may be tackling I&I in their local jurisdictions. So yeah, really the focus of the webinar today is on sort of innovations and innovative programs that are out there and kind of where we see the industry going in terms of tackling I&I and managing wastewater system capacity. Just as a bit of an agenda, we'll do a very brief introduction to Civica for those who may not be familiar, and then to get into sort of what the problem is, defining what the problem is, starting to dig into how we determine system capacity, where to get started for new developments and options available to you, whether you're working for a municipality or you're consulting with the municipality or have some aspect of helping municipalities manage capacity in wastewater systems, where you could potentially get started, and some of the programs that are going on in various jurisdictions that may be available to you in terms of options of expanding your programs or building a new program or looking at certain aspects of a program that may be helpful, and hopefully you get a tidbit of information that's helpful for you or your clients to push their narrative forward. We have some case studies, just very brief, a couple of examples, and really want to at least highlight a few lessons learned. There are many and they're always evolving, but did want to touch on a few lessons learned and then a bit of summary. And of course, I'll try my best to not ramble on too long and leave some time for some questions and some discussion at the end. So a little bit about Civica. So, Ed, who's on the call, started Civica back in 2012. And so we're going into our 10th year, and really our focus, most of our focus is on collection systems. We do a bit of work on the water side as well, but most of our work is helping municipalities grow and manage capacity in their collection systems, whether that's stormwater or wastewater systems, through the various services that we provide, and whether that be field services, going out, performing inspections of assets and flow monitoring, and looking at the system in the field, as well as the consulting side of things. So a lot of work that we've done in the past is on, the modeling side, looking at capacity. We do some water resources work as well, and everything up, as small as a sub watershed or a individual asset inspection, going out and CCTVing a pipe, to larger, higher level master plans and studies such as that. So everything from right down into the nitty gritty to those higher level studies. I'd say Amit did a very good job introducing us, so I think probably just skip this slide because I don't think we could have put it better ourselves. So I'll just dig it right into the content and the reason why we're all here today. So, when we talk about I&I, when we talk about inflow and infiltration, there's a number of sort of drivers in terms of why we want to reduce those flows. We see a lot of municipalities now and in the past invest a lot of money into basement flooding protection programs, trying to reduce sewer backups as much as possible so that ultimately the wastewater is not backing up during these large storms into residents' homes. There's a lot more awareness and push for environmental protection, so trying to reduce combined sewer overflows, sanitary sewer overflows, and bypassing a treatment plant. So another big driver for I&I reduction is to remove, what typically causes these things to happen, which is, a lot of the times it's melt or rainwater getting into wastewater systems and causing those capacity issues. There are some, costly infrastructure upgrades that are required. So when there is a lot of stormwater, for example, getting into a wastewater system, it often triggers the upgrade of a pumping station or a treatment plant, let's say, and those certainly have some significant costs to them that maybe could be avoided or at least minimized if I&I is taken care of, and if I&I is a problem in a particular area. Growth needs, and that's one that I'll probably focus most on today. If there are new developments coming in, and as we all know, Ontario is growing quite rapidly these days, if there are capacity limitations in a system, then there's certainly some need to hopefully create capacity through some of the programs I'll talk about today, so that those developments can proceed, and you can focus on how we plan into the future of allowing these developments, and how do these communities grow over time. And then there's certainly the regulatory compliance. So with the ministry's new CLI ECA regulations, which focus more on a consolidated, just in the name, consolidated linear infrastructure. It's really looking at the system as a whole and how it functions together. And so that's another sort of driver as to why you want to look at I&I on a sort of system-wide basis. And so, when we talk about some of the pressures we're experiencing right now, and as we continue to grow, and as we see that there's a large increase in the prices of homes, and the amount of growth that's happening around Ontario, we can see that it's happening now, and it's going to continue into the future through all the growth forecasts that we've seen, and the ministry's places to grow guidance as well. So there's a lot of growth that's happening, and it's causing a lot of strain on existing wastewater systems. Kind of to add to that is the climate change component, as to, there's certainly a lot of evidence and a lot of research happening that projects larger storms into the future. So how do we accommodate both a growing population and potentially larger storms? Again, focus mostly today on the wastewater system. So how do we make sure that going forward we're able to accommodate that growth while also making our systems more resilient? And so when we talk about I&I, what's the problem? So in the figure to the top right here, we see sort of a pipe. This is your ideal situation. So most wastewater systems are designed for wastewater flow or sewage, plus some, let's say, small component of I&I. So the system is designed to allow some I&I. But in actuality, we typically see, when we go into a municipality and we do further studies, that the actual case is that the I&I is higher than the design allowance. This doesn't always lead to issues, but one common problem that we do see, and a lot of focus, in City of Toronto with their basement flooding studies, is that when the I&I is too high, or wet weather flow is too high, then it does cause issues like basement flooding. And so really, when we talk to municipalities and we're working with municipalities, there's a lot of conversation around either a lack of capacity in a lot of areas where there is sort of a known issue, or a lack of understanding of the capacity within the system. So a lot of municipalities are still in the process of collecting that information, whether that's monitoring and modeling, to see where maybe some of those pinch points in the system are, where they may experience capacity constraints in the future. And so how do you accommodate growth and in a reasonable and sort of responsible manner, if you're not really sure what the capacity is? And we see, and we've been working with a lot of municipalities and developers over the last 5-10 years, as to, there's a lot of developments that are either being delayed or canceled, or looking for solutions to that capacity problem. Like, how do you approve a development if there is not system capacity? And then again, going back to the point before, in terms of, typically it's a treatment plant or a pumping station downstream, and there's quite a bit of design and construction costs associated with that. And it takes time. So, there's quite a significant amount of cost to do some of those work, and it takes a long time to do a lot of those system upgrades. And so, at least in the interim, is there other options and other solutions that you can do to accommodate this growth while still building some resiliency into the system? So when we talk about determining the capacity of a system, a lot of the time this is something that is assessed as sort of part of these higher level studies, whether that's a master plan or a pollution prevention control plan. But there are now tools available, and really those happen let's say every 5 years or every 3 or 4 years, let's say, for some that do it more often. But there are tools available to be able to do that more frequently, to get an assessment of the capacity of your system without having to wait for one of these studies to be completed. So one of our big pushes is to try and make this as live or as in sort of near real time as possible. So we have certain tools and system in places through monitoring and modeling and reporting to municipalities on a very frequent basis, so they can get an understanding of what the capacity actually is in the system. And typically you set this up once, and then it needs to be maintained, but it's a self sort of perpetuating system that will give you a good understanding of what's going on at a municipality level, let's say. There are tools available to sort of drill down at a more local level. It's the same types of tools that are used to assess capacity at a higher level, but really when it comes to assessing a particular subdivision or a new site plan, let's say, a lot of the push that we've seen, and I just have a screenshot from the City of Toronto's sewer capacity assessment guidelines, is that drilling down and refining that information, refining the flows and the models that are going into making those decisions to assess capacity, really can be drilled down using flow monitoring or depth of flow monitoring, visual observations, going out during wet weather and looking at these systems, how they're performing during some of these events. And as I've already talked about, the modeling and connecting the monitoring and the modeling together to make sure that it's constantly updated and what the capacity is at a particular point in the system. So a question, and I'll get to it more towards the end, but essentially if you don't have guidelines, or if you don't have an assessment or an understanding of how you would put something like this together, it's certainly something that is out there. It's widely available, and if you need help pointing to resources, feel free to reach out, and we can certainly connect you to where that you may find something like that. And so how do you get started? So typically, this is usually how we see it, is that in terms of growth and new development, when these subdivisions or these site plans are being put together, they're then submitted to a municipality, and a capacity assessment, for example, in City of Toronto is a requirement. So as part of putting in a new infill development or putting in a new subdivision, a capacity assessment is sort of automatically triggered to see if there is capacity in the downstream system to accommodate those flows. And this is, compared against what was there previously. So if it's a 2-story existing building and they're tearing it down and putting it in a 20-story, we're putting in the change in flows, but also comparing it against the capacity criteria. We've talked to a number of municipalities, and typically, when you're taking on this additional analysis, there may be a need to either create a fee to do a review of these site plans or subdivisions, or revise their existing fees so that they have the resources, whether that's to hire somebody internally to do that work, or to hire a consultant outside that can act as your sort of in-house modeling and capacity assessment team to make sure that, again, as these new subdivisions are going in, or these new developments are going in, that there is capacity in the downstream system. And, as I mentioned, the City of Toronto's guidelines earlier, there are protocols in place to do flow monitoring and I&I estimation. And in particular there, if recent data is not available, or if it's not granular enough to get an assessment of the capacity in that particular location. And so, digging a little more into the details on that. So when we talk about assessing, assessing these flows, we typically check under a couple different conditions. So you have your sort of typical design flow, which I talked about earlier, which is that wastewater or sewage component plus that minor bit of I&I allowance. It depends on which municipality you're in, but it varies anywhere between 0.2 to 0.4 liters per second per hectare, let's say. And that in itself may trigger some concerns in terms of capacity, but then there's also another additional requirement to see what's happening during some of these larger storm events. So, typically, I think City of Toronto uses the May 12, 2000 storm. York Region, it's more of a 25-year storm, but depending on where you are and what sort of level of service and amount of resiliency you want to build into the system, you typically assess the flows again under some of these more extreme conditions. And if the sort of criteria is not satisfied, so if the hydraulic grade line, as part of the modeling exercise, if you get a hydraulic grade line analysis that says that the water level in the system is going to be closer than 1.8 meters below grade, or whatever that assumption is for that interaction between the basement and the grade line in the sewers, then there may be some mitigation, wet weather flow mitigation measures required. So if it's too close to causing basement flooding, or another way that we assess it, if it's going to cause excess or additional CSO volumes, if you have a combined system, then that triggers this need to do some sort of mitigation, this wet weather flow mitigation. And this is the preferred path now in the City of Toronto, where if this is triggered, then the next step is to do some sort of I&I or wet weather flow reduction to make sure that the capacity in the system isn't being at least made worse. And so when we talk about I&I programs, we typically sort of run three different types of programs at Civica, but in a broader scale, this is typically how I&I is sort of thought about. So we have the new subdivisions, I&I prevention. So trying to make this new infrastructure, and as things are getting developed out, trying to prevent I&I at the inception of that new development, at the inception of the new infrastructure. So really the key focus of that program is on the standards and guidelines for development and how the infrastructure is going into the ground. We've been involved with York Region the last 5 or so years, performing flow and rainfall monitoring to see what the effects of these enhanced construction standards are on the flows in the system, to make sure that they're hitting targets that they're looking to hit. And I have another slide on that in a second. And then some conformance reporting, kind of making an assessment of how effective these measures are and how that's turning into, ultimately the flows and the capacity that these new subdivisions are taking up in the wastewater system. The second aspect of most I&I programs is I&I reduction. So going out to existing developed areas with existing infrastructure, performing flow monitoring, various sewer inspections and testing, identifying defects and ultimately remediating those defects. And then a big component of that is typically a stakeholder communication and engagement piece, because you are going into existing areas with homes that may have defects. And so when you look at the ultimately remediating those things, whether that's through a subsidy program or a developer-led program, there's a lot of communication and stakeholder engagement that has to happen, both with the municipality and with the residents themselves. And then finally, ultimately, hopefully, the I&I reduction piece comes first. To try and reduce those flows as much as possible. The final step would be sort of I&I acceptance. You've done all these cost-effective remediation activities, and now you need to see, okay, what ultimately are we going to accept? What does that what does that do? What is the impact of accepting that on the capacity of the system? And you start to develop those alternative solutions, whether that's pipe upgrades or pumping station upgrades, and then ultimately design and construction. And that's similar to a master planning type activity that you would do to assess what you need to do when and how much those things are going to cost over the next 5, 10, 20 plus years. And so I wanted to highlight a couple of some results that we have from some of the work that we've done in York Region with their existing, their new subdivision I&I prevention program. And the MEA and I mean, I think you were involved at one point. The New York Region did a presentation. I forget, maybe middle of 2021, on some of the more on the background on the standards and the guidelines and some of the construction practices that were happening. So I encourage you, if you haven't seen that webinar, I think MEA posts everything on their website, so you can go back and see, kind of, again, dig into more what they were doing on the standards and guidelines side of things. But this is more again on the results of the flow and rainfall monitoring and sort of assessing what they were doing and how these subdivisions were being built out to ensure that they were hitting these lower I&I levels that they set out to do as part of their new subdivision I&I prevention program. So there's a lot going on this slide, but essentially what I wanted to highlight was that we have the region's design criteria, so that 0.26 liters per second per hectare, which is the design criteria for their wastewater system. The limit for this program, because they were enhancing the construction practices and they were trying to make it as sort of leak-proof as possible, was to try and hit a limit, an RDII, so a rainfall-derived I&I rate of 0.125, 0.12 liters per second per hectare. So basically half of their design criteria was what their target was for this program, so that they were trying to hit these lower flows. So we have a number of developments that we're monitoring, over 20 to date, and they typically do 2 periods of flow monitoring. One, when the first connection is made to the sewer on the streets, and then so that triggers an 8 to 12 month monitoring period, and then another 8 to 12 month monitoring period at 85% occupancy of that particular subdivision. So that's what you see when you see period 1 and period 2. And so just even looking at the difference or the amount of I&I that's coming out of these subdivisions during period 1, the average was 0.16. We had 15 of the subdivisions out of these 22 that were in conformity, so less than that 0.12 limit. So pretty successful already, without really having other programs to lean on to know exactly where they were going to end up. And then we were able to identify a couple of these that were sort of way out of whack, way out of conformity. We implemented some measures. So we were doing the flow monitoring for period 1, and those that had higher I&I than what the target was for the program. We went in, we identified areas that could be rectified, and just highlighting a couple here where we were able to identify a couple issues. There were some sanitary maintenance holes that were low-lying and susceptible to flooding, so go in, seal those, make sure the catch basins around them are working properly, and get that I&I back down to a more reasonable level. So, period 2, and this is, a lot of these are still going through some monitoring and reporting, so it's not, by no means is this the end of the program or the end of the analysis, but so far we have 0.1 liters per second per hectare, and all but 2 are in conformity at this point. So just I kind of wanted to highlight this as a potential option if you're a municipality and you're looking at a program where you can try to reduce I&I at the inception of this infrastructure. This is really a good place to start. I just wanted to highlight, and again, encourage you to watch the MEA webinar with York Region around the standards and guidelines. It's really the backbone of a program like this. There's a lot of clear sort of expectations and understanding within the guidelines as to sewer installation and performance testing that needs to happen. I believe York Region's building out their flow monitoring requirements and trying to make it as clear as possible for all of those involved that are doing the flow monitoring and reporting. So there's some good literature and good information out there if you're looking to again implement some of your own programs. I know Ed's been working with the MECP quite a bit on these new CLI ECA regulations. So I think some of the language is going into those as well, and making sure again that at the inception of this infrastructure, the I&I is at and ideally below and much below the design criteria. Even if you don't have these standards and guidelines quite ready yet, it's probably worthwhile to at least monitor some of these new subdivisions if they've been in a couple of years, 5, 10 years, just to see, if you haven't done that yet, to see how that infrastructure is performing, and to kind of inform whether you need a program like this. A couple lessons learned from this program. I mean, I go back to this, whether this is a new subdivision or an existing subdivision, but we've really identified lately that maintenance holes, these low-lying maintenance holes, doesn't need to be, I mean, there's a lot near sort of river valleys or in river valleys, and as the river or stream goes up, a lot of them get flooded. So those are significant sources. We find a lot of those. But even on the streets, this is a picture from a new subdivision. And you can see, the storm manhole, but you can't actually see the sanitary one. It's underwater. And so you can just imagine how much flow is getting into the system through that. And so that's really a big focus for us lately, and what we've identified lately as one of these key contributors to I&I. Again, both in existing and in new subdivisions. The second point is, a lot of these sources are only active during large storms or during snow melt. It kind of makes sense if I&I is a problem, if it's a wet weather issue, you kind of need to be out there during these storms to see what's going on. So we really do encourage, and we're building more and more into our programs, what we call wet weather inspections, to make sure that we're out there and we can see what's going on during these storms, and we can identify where these locations are that are more susceptible to flooding, let's say in this particular example, and we can come up with remediation alternatives for things like that. Just another point on the inflow through the manhole covers. We are working more and more with dual drainage analysis, so looking at where the most potential for surface ponding is, both on the road and off the road, but a lot of it's been focused on the road. And we have some other articles that we're producing in a webinar coming up probably end of February or into March on some of the work that we're doing and some solutions to looking at where these areas are, and how you could potentially solve some quick wins on the public side with sealing some manholes and finding where they're most susceptible to flooding. Another lesson learned for us on this program is that you need a very robust data collection and management system. This is strictly for the flow monitoring side of things, but we're building out more and more tools as we go through, and we're managing I&I programs to manage even the asset inspection side of things. Every time you go out and collect a piece of information about a particular asset, this is certainly something that we want to collect and be able to show in a sort of cloud-based platform or and have the ability to create tools and ways to analyze this data to quickly convey and share with the stakeholders involved in the particular program. So this is just a stat I pulled out this morning. Through this program alone, we collected over 10 million data points. When you're talking about rainfall data and level data and velocity data to calculate flow. So it's just it's a very big data management and data analysis job. And so having a platform like Data Current that we use, you can get sort of real-time access to the data, alarm the data, and we've implemented and integrated a lot of analytics to sort of automatically calculate various parameters, whether that's INI, liters per second per hectare, INI rates and volumes and whatnot, and really trying to put it into more of a dashboard so you can quickly go on, log in, and see what's going on, again, to get that snapshot of the capacity in your system. The second innovative program I wanted to talk about was the developer-led INI reduction program. So this is a program that I know Ed was one of the sort of key directors and guidance and technical advisors at the start of this program. And this is a program we've been working on in York Region. At least that has been for at least 10 years, and we're starting to sort of permeate into more municipalities across Ontario. But essentially, through this program, we've been able to accommodate over 30,000 people or population worth of flow through INI reduction activities. So lots of treatment saving costs and a lot of ability to then taking development charges, over 200 million in this particular case, 95 of that, which is directly sort of contributed to the wastewater component of the development charges that are obtained by York Region. So, that's just sort of a high level sort of intro to the program, but what is this? What is a developer-led INI reduction program? So this is a program where the developer investigates, identifies, and remediates INI in existing areas in exchange for servicing capacity, sanitary servicing capacity in the existing system. So the reductions are typically targeted in the areas around that development or downstream from that development, and that will offset the flows that the new developments are going to put into the system. In York Region, it's governed by a tri-party agreement. In City of Toronto, a lot of it's been at a site level, so a lot of infill development, so a lot of it is governed at the site plan agreement level, which really sets sort of those clear expectations for the parties. The main role for the municipality is to kind of oversee, review, and approve all the work. So, proposed investigations, system remediation, and really this leads to less staff time having to be involved in a program like this. It's more again, led by the developer, so that they have to go out, find these issues, find these defects, and ultimately fix them. But at the end of the day, we see it as a win-win-win. The municipality gets to reduce INI, the developments are allowed to proceed, these development charges are generated, and in existing areas, we've gone onto public property and private property and fixed defects on both, again, public and private property. So we see it as a pretty big benefit to all parties involved. York Region's currently using that as part of their reporting of INI reductions to the MECP as well. So just another sort of added benefit of the program. And really, we see this as sort of another tool in the toolbox. So, we've done most of this work and a ton of this work in York Region. So these developer-led initiatives have reduced about 20% of their overall reduction as part of their INI reduction mandate by the MECP as a condition of approval for the Southeast Collector Sewer. So their goal is to reduce 40 million liters per day by 2031. And these developer-led initiatives have been responsible for almost 20% of the reductions that they've seen to date. So it's still going to continue for at least the next 10 years. And it really supplements, municipal-led programs and projects that a lot of municipalities are already doing, including, specific I&I projects, but also state of good repair programs. So your regular CCTV and asset inspection programs, and then these other studies and master plans that may sort of target and have some sort of operation and maintenance or I&I component to them. And so one of the sort of best and biggest benefits, I guess, to this type of a program is this sort of what we call a net benefit component. So typically the way that we've structured and the York region has structured, and it varies municipality to municipality as to exactly what ratio is used. But essentially what happens as part of these programs is that the developer has to reduce at least twice as much flow as they're putting back into the system. So how that works is if you have a development that's contributing 100 liters per second, let's say, of flow to the wastewater system, then they're responsible for reducing 200 liters per second, but they're only allowed to put that 100 liters per second back into the system. So, it's at least a 2-to-1, and depending on where we're doing the work, it goes up to as high as 3-to-1 in some, 4-to-1 in some locations. And so it builds in a little bit of a factor of safety, but also it allows the municipality to generate extra capacity that they could use for other priority projects, whether that's, intensification or affordable housing or anything like that, the municipality is looking to get some extra capacity for. And so some highlights of the program, and I already mentioned this a little bit, but we've been able to, and we've done a number of projects in the past to free up capacity for this growth in a timely fashion, and ultimately to try and reduce the amount of new pumping stations and treatment plants.
All right, apologies again, everyone. I can assure you that the problem has been resolved completely now.
Okay, I will. I'll try. I only have a couple slides, so I'll just try and wrap up quickly, and then if there's any questions, I'll try and leave some more time. So yeah, essentially the goal of this slide essentially was just to kind of show the amount of growth that can be accommodated through a program like a developer-led I&I reduction program. So over 16,000 that we've been able to do, and this is actually a little outdated, so I need to update the number a bit, but you get a sense of what's going on. And so this is after that 2-to-1 or higher ratio. So over 30,000 actually accommodated through a program like this. Some lessons learned, a robust communication plan is key. As you can see in the picture in the back, this is some smoke testing we did in, I think it was Richmond Hill. So when you have smoke coming out of people's homes, you can just imagine the types of calls you may get. So having a very good communication plan is key for this. A lot of the risk for doing remediation work on private property, which is a big sort of challenge for a lot of municipalities, is transferred to the private proponent as part of these works, which is a big sort of benefit that a lot of municipalities like from a program like this. We usually recommend stakeholder sign-offs at multiple checkpoints when you're doing work on people's homes, for example. So when we're going to do a catch basin disconnection or a downspout disconnection, making sure that they sign off before the work is completed and after the work is completed to say that they're satisfied with the work really gets a lot of more buy-in for a program like this. And then we also encourage warranties periods. So, at least a 18-month warranty period for all works as part of the York Region program is required, so that if there are any deficiencies in the remediation work, then they must be fixed before the end of the program is completed. So just a summary, there are guidelines and policies and various sort of I&I and wet weather flow reduction strategies out there from existing municipalities. If you do need help, finding those things or putting together your own, feel free to reach out. Happy to help facilitate, finding those and helping you on your journey. Flow monitoring and modeling, these are relatively fast and cost-effective ways to really get a better understanding of system capacity and very good tools to have in your tool set. And finally, I&I prevention and I&I reduction are solutions that help create capacity. They can save time. Time's a big component for a lot of especially growth-related needs, but also money and ultimately putting dollars in the best place to try and reduce flows. So you're not treating that flow and conveying that flow into the future. Ideally, you get as much of that flow into the system as possible beforehand. And both of these programs are being used throughout Ontario to help mitigate some of that risk. So with that, I'll wrap up. I want to leave a couple minutes. If there are any questions, I'll just leave this slide up so you can see some of our sort of capacity management services and some of the things we do. But again, thanks to MEA and thanks to everybody for coming out and attending the webinar today, and apologies for the technical difficulties.
Thank you, Matt. And yeah, thanks for everyone for attending. Luckily, I didn't notice any questions come in before we had the glitch, so we didn't lose any questions from before. So now with the presentation concluded, I'd like to invite everyone to please ask your questions if you have any questions, or would you like to learn more about inflow and infiltration management and tracking. I can remind you that if you're not comfortable typing in a question and you're more comfortable asking it verbally, just click the raise hand button at the bottom, and we'll be able to invite you to a discussion. I see no questions coming in yet. Maybe I can start with one. Matt, what are the current municipalities that are giving more focus on monitoring inflow and infiltration, and what are the unique findings that they saw after implementing such programs?
Yeah, I mean, there's quite a few, I would say, and it depends on where they're at in sort of their life cycle of whether there's downstream issues. If there's, we've been approached quite a bit lately by municipalities that are running into capacity constraints at treatment plants and pumping stations. Certainly when you look at the monitoring programs that are out there, City of Toronto, I think, has 300-400 flow meters, York Region about the same, Peel. So some of the larger regions are certainly installing and maintaining quite a few monitors, but elsewhere, yeah, all around Ontario, there are municipalities that are doing some level of monitoring. I think really for us, it's connecting that to a more sort of at your fingertips assessment of what that means for your system, not waiting to the end of a year-long monitoring program, or modeling initiative to get that assessment of what's going on in terms of the capacity of the system. So I think, you know, where it's ultimately going, and you'll see, I think region appeals probably on the forefront of some of this work in New York as well, as and probably in Toronto as well. But you know, trying to tie these models and these sort of more real-time analyses and results that they're getting to more control in their system. So there's, you know, terms called like digital, you know, I want a digital twin. I want to have the ability to do real-time control and have a little more, again, control, and not just waiting to see what happens during some of these storms to see what's going to happen. So I think that's kind of the direction that a lot of municipalities are going, is to make it a more hands-on and proactive approach to ultimately, you know, saving capacity and reducing these negative consequences, whether that's basement flooding or bypassing or overflows. I think that's ultimately the goal that a lot of these municipalities go to. I mean, I understand not everybody has the resources as some of these large ones, so it's scalable. It doesn't necessarily need to go to that level, but that's certainly a direction I think a lot of places are looking to get to, is a little more hands-on and sort of real-time, if you will, analysis of their systems.
I can see another question coming up from the audience. Someone is asking, what happens when inflow and infiltration reduction strategies are implemented and then those strategies fail after the development has been built? So what are the other approach or mitigations that municipalities should consider or could consider if such a scenario occurs?
Yeah, I mean, you know, typically when we talk about I&I reduction, and we've done quite a bit of this work, we're looking for, you know, and York Region has been very clear that they want permanent solutions. So things like catch basin disconnections or roof drain disconnections or sump pump disconnections and all that. We're really trying to focus on the permanency of those solutions, of those remediation activities. So ideally they don't fail. If you know, take out a catch basin and reconnect it to a storm sewer, let's say, or a nearby green space, ideally that wouldn't you know, ever get connected back to the wastewater system. I think Ed was mentioning as well, you know, there's this as part of our strategy, as part of the assessment of reduction, is that when we find a particular defect, let's say, as a simple example, a catch basin, we are quantifying, we're going out and, you know, measuring the amount of flow that is going, or the contributing area to that catch basin. So each defect gets quantified individually, and we build in that sort of net benefit capacity, so 2 to 1, for example. So ideally that doesn't ever get back to the system, and if there are factors of safety built in, but again, most of the solutions are meant to be as permanent as possible. You know, when we do something as simple as a downspout disconnection, you know, we're putting in a concrete plug into the connection down to the foundation drain, and landscaping over top of it, and putting it out to a nice place on the lawn. So it makes it, you know, not impossible, but very, very difficult for a homeowner to reconnect it to the system, as an example. So, and then I guess as Ed has mentioned, is, you know, continuing to monitor and make sure that the reductions that you're seeing and modeling are actually happening in the system, so that you can ultimately have confidence that the reductions that you're seeing are actually happening in the system. I hope that answers the question.
And your answer was clear enough to me, if the person who asked it still more needs more clarity, feel free to type in the questions again. And if anyone thought of a question afterwards, I see that Matt has his contacts info on the screen. So if you can send him an email, ask him with a question afterward.
Absolutely.
There you go. I see another question coming up. Does York region have permanent monitoring stations in place in the collection system? I'm not sure if you would be able to comment on that, but you can go ahead.
Yeah, I mean, you know, Ed's pretty familiar. I'm fairly familiar with York Region. I don't know what percentage. I think in one of their strategy reports, they say how many they have, but they have critical points, at least in the trunk system, and in a lot of areas where there's connections to their trunk system where they are monitoring. So let's say 50 to 100 are permanent of their 350 as a sort of ballpark guess, but I know they do, yes, maintain a permanent flow monitoring network. I don't know, Ed, if you want to build on that or if you have more insight there.
Yeah, I can do a little bit more. Yeah, most of them are permanent. I would suggest they do monitor the local systems as well as the trunk systems. So they are permanently monitoring the local sewer systems, which are owned and operated by the local municipalities. As you may know, or if you don't, York is a two-tier municipal system whereby the sanitary sewers in York, in the local municipalities, at least not the trunks. The large trunks are owned, and there's a criteria which ones York owns. Above, I believe, is 375 or 400 are owned by the region, and they cannot be local connections and so on. But then the local municipalities own the sanitary sewers, all of them that fall outside of that criteria. Unlike Peel, for example, that Peel owns all the sanitary sewers, regardless if they are small or large. So York Region has permanent flow monitors in smaller basins. Now, these are not SSES basins, meaning that they're not very, very small, the catchment areas. So they do have about 300 flow meters. It may fluctuate a bit year to year. So they divided the entire YDSS, which is the York-Durham sewage system. York has other local sewer systems, but the main one is the YDSS, which is these main growth areas that are connected to Durham eventually, and the treatment plant is the Dolphin Creek treatment plant in Durham. So yeah, they do both the regional sewers as well as the local sewers.
Thanks, Ed.
All right, thank you, Ed. With that, you see the time is 5 minutes past 2. We can go ahead and end the webinar. Again, apologies for the technical difficulties, and I hope we answered everyone's questions. The recording will be available on YouTube on our page, and we'll repost all the links to the YouTube webinars on the MEA website. Again, I would like to thank Civica and Civica team, Matthew and Edward, for joining us and presenting today and sharing their expertise and knowledge. Thank you all.
Thanks, everybody. Take care.
Take care.
Bye-bye.